Hello and welcome to the show. My name's Relva. This is Do All of the Things. On today's episode, a water cooling experiment. I'm gonna put together a passively cooled water loop with no pump. I have no idea if this is gonna work. Let's find out. The MediaBox PC is one of the funnest PCs you can build. Why? Because you can take the conventional rules of PC building and just yeet them out the frickin' window, bud. You see, at one point in human history, if you were a computer geek like me and you were into the privateering, before we had streaming, before we had Android boxes and internet-connected consoles and smart TVs, if you wanted to watch digital content, you could only do it on a PC. That, and because you were downloading these movies online and the internet wasn't as fast, you'd have to leave your PC on overnight to do that download. And then of course, that digital file, you needed a PC to watch it on. So the thing to do was to build something called a MediaBox. It was either out of scrap components, spare components, or if you spent the money, low power components. So you weren't burning a lot of hydro leaving this thing overnight, because of course, our PCs back then could pull 200 watts out of the wall sitting still. And then the other purpose of it was to connect to your TV. It was a PC you bought to connect to your TV, which was rare back then, because TVs didn't have HDMI. They still had composite or S-video. You needed a special video card to do this. Now, of course, these are all things from the past, and it's not as practical these days when you can just grab a Fire Stick or something, plug it into your HDMI, and boom, you're streaming. But I'm old school, and I'm a computer geek, and the need to have a streaming device is another excuse to build a computer. And like I said, you can have fun with it. As an example, this guy right here. This is my living room centerpiece kind of PC. Its purpose in life is to not only stream, but look good. As such, it's very simple. So what do we have here? It looks like something resembling a high-end gaming PC, but it's not. It is a hard-tubed water loop. We've got an EK Evo non-supremacy block here. We have an AlphaCool Monsta 240. That's a DDC pump, and then, you know, a tube res. Now, just about every part in this computer I got used for cheap. The only thing I bought new for this PC was the CPU and the tubes. And what is the CPU? It's a 3200G. It's just an entry-level APU. And then we have 8 gigs of HyperX, 2400 if I recall correctly. This isn't high performance at all. As you can see, there's no video card. We don't need a video card. We're just streaming, and the outputs in the board from the APU are all we need. Now, yes, it has a X470 Strix motherboard, but that's left over from my main system. That was actually my main gaming board with my 2700X. Then when I upgraded, I wanted to build another MediaBox, and I'm like, well, I'm just gonna flip this board, buy another board. I might as well just keep this board. But when I talk about throwing out the rules, what you're gonna notice, there's no fans on this radiator. There's none underneath. And then these fans here, the exhaust fans, they're not even spinning. This thing is being passively cooled by this radiator alone. Because of natural convection, it can draw cool air in from the bottom, and then it just kind of rises out. And these fans are calibrated in an AI Suite Fan Expert so that when the ambient case temperature hits a certain threshold, they just kick on and exhaust out some of that heat. But they don't run very often. They spin up occasionally while I'm watching television. On top of that, the power supply, a gold-rated EVGA, it's in its eco mode or whatever. Its fan's not spinning. A good power supply, only having to push this TDP, doesn't even get hot. This entire system pulls maybe 20, 25 watts out of the wall, and that's while streaming the content to my television. It's built to look good in my living room, be as completely silent as possible. And yes, DDCs can be quiet if you speed control them. That's a PWM controlled one. It's running as slow as it can. And to top it all off, there's a little bit of dust buildup. Yeah, but guess what? I haven't cleaned this thing since I built it years ago. Because there's not a lot of air circulation, there's not a lot of fouling. Next up is the evolution of my OG MediaBox. This case was purchased in the early mid-2000s. I called this computer HAL 3000 because it kind of reminded me of the HAL eye there. And this strip here lights up, normally just full on with the power, but I rewired it to be the HDD light. So this glows and blinks as the computer's thinking. So further adding to the HAL effect. Cases designed for media PCs were unheard of, and this was one of the first, made by a company called Simple I do believe. Right now, it currently has a 2200G on a B450 board. I think that's about 8 gigs of, what is that, a rip jaw? There's a Silverstone SFX power supply. It had a panic mode fan. The fan ran too much. It's gold rated. Didn't get that hot. I put a Knock 2 on it that's being regulated by the AI suite. And then right here, this is a little some special piece of history right here. This is the granddaddy of the Hyper 212. This is one of the first, if not the first, tower cooler on the market made by Cooler Master, and it was mind-blowing in its ability to cool a hot running 9600 Phenom. Yeah, like it was impressive. And you can see I got the fan on it right now, which is only on it because I was using this PC to film the Duke Nukem 2001 playthrough. So gaming on the PC got the CPU a bit hot, but for streaming, we don't even need this thing. Just that tower cooler alone sitting there is enough to give that CPU all the cooling it needs if we're just streaming. If you're not getting the theme here, it's that a basic process, like just streaming, doesn't burn a lot of TDP, does not create a lot of heat, which gives us the opportunity to have fun with these systems and make them super, super quiet. You compound that with the fact that we don't even need hard drives or anything anymore. Just stick an NVMe in there. Oh boy. And finally, as part of our feature presentation, this guy right here. This is an Athlon 200GE. It's a 2-core, 4-thread Ryzen processor that they didn't see fit to put the Ryzen branding on it. And of course, it's the lowest TDP of the bunch. And at one point, I found this heatsink from Arctic Cooling. It is just balls out a big chunky chunker aluminum heatsink for passively cooling Ryzen CPUs. Due to the lack of airflow, I found the chipset ran a bit hot. You remember these guys, the old Zalman chipset coolers? Hell frickin' Arius, bud. But this is about as simple, cheap, and basic as a media box gets. Now, yes, I have a Corsair gold power supply on it. I think I paid $50 for it used. That's one of the key things. We want gold rated because we want that low power consumption. But again, this guy only burns like 20 watts out of the wall, so that fan doesn't spin. We only have 1 stick of RAM, 8 gig single channel. We don't need dual channel just to stream. Corsair MP300, that's only a PCI Express 2-lane NVMe. So again, not full speed. This is just, we threw together the cheapest stuff to make a PC to stream. And this is actually the one that I'm gonna rebuild because this whole process that I'm going to experiment with depends on the fact that we're using extremely low power components that are creating very little heat, and then maybe we can get away with it. So a passively cooled water loop with no pump. How does that even work? How do you circulate that water? Well, to explain that, I have to take you to the basement and show you my water heater. In a poor design decision made during a renovation, the hot water tank was moved here into this room all the way at one far end of the house. And you see, the problem is the kitchen is all the way at the other far end of the house. What this means is that if I want hot water at the kitchen sink, I gotta run it full blast for probably at least 2 minutes before the water gets hot. The offensive, wasteful Band-Aid solution to this problem was to install a hot water recirculator. That's this right here. You see, the hot water comes out of the tank and goes through the lines up to the kitchen like normal. But at about the kitchen sink, there's a T, and then there's this return line here, circulated by this pump, and there is also a check valve, which is important. Now, I find this offensive because it's wasteful. Not only do we have this electric pump running 24/7, but by keeping hot water in the lines, that water can cool, wasting heat. I decided at one point to make the best of that situation by wiring up this pump to a switch. So there's now a switch in the kitchen. I can turn this pump on and off from up there. Now the funny thing is, I almost never use this pump. You see, just the act of having this recirculation line installed does the job. It's not quite as hot. You will get just slightly hotter water if you turn the pump on, but that line gives hot water the opportunity to circulate even without the pump. Why? Well, because of pressure changes in natural convection. You see, as the water gets heated in the hot water tank, well, heat causes things to expand. That causes a pressure increase. That pressure wants to go somewhere. Now, because we have this whole loop where the water can sit and cool, well, cooling causes things to contract, that causes pressure to decrease. So what do you think happens when we have a decrease in pressure in the line and an increased pressure here? Well, the hot water forces its way into the line. As the water in the line cools, it decreases in pressure, returns back to the tank, and then the fresh hot water forces its way back into the line. And this is regulated by this check valve. This check valve will only let the water flow in one direction. If it wasn't for this check valve, the pressure in the line could just kind of self-equalize and the water wouldn't really move very much. Probably a little bit because of natural convection. Remember, heat rises and the kitchen's up. So hot water from here wants to go upwards towards the kitchen and the cool water in the pipe kind of wants to come back down. But because of this action of expansion, contraction, augmented by this check valve, it causes just a nice pumping action through the line. I find the result is I can still get fast hot water in the line. This pipe is warm and the water, even though I have not used the water for a while, this is blistering hot. Water is flowing. So, the purpose of this exercise today, this experiment, is to simulate that process of natural convection and expansion, contraction, pressure pumping to have a fully passive water loop and see if it's going to work. And well, I kind of expect that it's not going to, because the hot water heater, it gets the water up to a much higher temperature. So like in theory it should work, but I don't know if we're gonna have enough temperature change to actually make it work. But either way, let's look over the usual suspects here to see what we're gonna use to do this. We got one of these pumps I keep wanting to try out. Quality's a bit iffy, but they are kind of nice. They're just direct PWM and they're pretty quiet. And this is because I don't expect this is gonna work very well. I'm gonna have to put a pump in it. But I got myself a tubular res here and a 90-degree fixed fitting, not rotary. I did manage to find this timed up correctly. Here's an EK fitting, just coupler. And then one of our key components is an alpha cool check valve. Now what's funny is you can kind of adjust on this by turning the little internal assembly. Stock, there's not a lot of excursion. Like that check valve doesn't open very much, but I guess that should be enough. And then you see we're gonna go direction out from the reservoir through the check valve. Now, because I underestimated how many of these things I was gonna need, I got a couple more. And then here is a T that is bigger than it needs to be, and a valve for draining and filling. I'm gonna leave that off for now. The valves are interesting because like you can't turn it unless you loosen the screw and then it turns. But then the valve is loose. So it's weird. I guess this is a feature, not a flaw. It's a locking valve. Once we snug up that screw, it can't accidentally be turned, which at first I'm like, WTF, but then I'm like, okay, that's not a bad idea. And then of course plugs, a couple plugs. I gotta be going 3/8 pipe, and I have a bunch of used EK compression fittings that I acquired years ago. And you know, I got some of these used too, or they might have been new. I don't remember. I got various rotaries to make ends meet. The case is gonna be this Canadian brand. It's a Turtletronics V1. I kind of got stoked on a Canadian branded case, but it turned out it's no good for a serious build. There's not enough airflow. Like we got 3 fans in the front here, but like, do you see how much actual intake there is? Those fans do nothing but circulate the air. So they're just gonna run dead slow. They have lighting on them, but not proper RGB. A little bit of bling. But one of the other downsides of this case is it's hard for it to take serious water cooling. You saw me do a water cooling build in this before, and I had one 120 mil rad across the back. We cannot fit a proper 240 across the top, like it goes. But you see where the motherboard is, basically, if we put fans on this, it's not gonna clear the motherboard. However, because we're going passive and we don't need to put fans on it, we might be able to cram the motherboard in there. And then being at the top of the case, it's just gonna let heat naturally convect out, and that convection should help draw air into the case. But yeah, I guess we're gonna start building. Well, let us quickly check the fitment here, because yeah, just. See what I mean? If we have fans, we wouldn't, like, it wouldn't fit. So, it's gonna have to move these standoffs upwards. And we're gonna have to put the stock back plate back on for this install. So the water block that I'm gonna be using is this EK Supremacy Evo. I bought it used and it came stock for Intel, but instead of just buying the adapter kit, I just fashioned this acrylic plate to hold it into place, and then I slammed some RGB on the bottom of it. Oh, look at that. It's not going to clear this RAM. That's fine, we don't need it to. We're going to have intake bottom, outtake, or output at the top, further enhancing that natural convection. Except as is the theme of this hacked mounting, there's hacked mounting hardware. Got like long screws that I cut the heads off, made studs, just screw into the stock backplate. Those lock nuts bottom out, we'll snuggen them up a bit, drop shmoo, or too much shmoo. That should just slip on. Little hardware store springs, all sorts of little random hardware. Well, not random, it's all kind of put together to do this. Actually, I'm gonna put some washers there first, under the springs, that'll be nice. And then washers over the springs. And then once the washers are over the springs, we secure it with I got these wing nuts. Oh yeah, it's super pretty, bud. But this is like used parts Gorilla water cooling. This is how I like to roll sometimes. And this is not for the amateur because, you know, we could over torque this, but I kind of have a good feeling for how tight I should be putting these on, so. Which those springs don't bear a lot of tension. They're almost redundant. I think I'm seeing a bit of shmoo ooze. Should be good. Now we gotta start getting ready stuff in here a bit. Like I gotta take these nice EK fittings off to keep a little bit of uniformity, but I don't even know what fittings I'm gonna need yet. I don't like these newer style EK fittings. You need a special tool to work on them. I'm good with the knurling, but I need to get this pupper mounted right up in here somewhere somehow. I have this assembly put together for the last pump that was in there, so I have to undo on this. Here's the mounting hardware that came with that tube res. So we gotta kind of figure out on this. You know, these, I guess, just snap in there. And then we have some sort of L bracket here. I guess we'll try to fasten these L brackets to this thing that I use. Those nuts almost want to push between the tines. That's funny, even though they're not tight, like, ideally if this was a serious build, I'd probably want to have some washers back here, but then like it might interfere because we have this line here, but I think that should be good enough, assuming our alignment is well enough. Oh, we got to put these things on and see. Just gotta like figure out what position I want to put this in. All the way out. All right, I think I got this assembly figured out, and it seems to hold tight enough that I think this is gonna work. Just gotta get her fastened into place via fan mounting points. That should do. All right, let's get this party really started, bud. Some of this is gonna be a tight fit, bud, but it is gonna be a fit. You know, at least this case has adequate distance from the back in which for the power supply to breathe. Maybe I should have plugged this in before. Ho, 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 ho. Just, eh? Oh, look at that. Just fits. Haha, ha. I don't need top audio. USB okay. Front panel okay. No, we can do better. Yeah, come on. Yo, what are you stuck on that you weren't stuck on before, bud? You gotta check out this half-assed RGB that I have. So this guy right here came out of a light bulb. You got a direct from China RGB light bulb like this, and they'll have RGB controllers often built into them. Here's one that I experimented with already that didn't turn out to be useful to me. But in this case, it had 3 parts. It had the RGB LEDs, and then it had a little 12-volt switch mode power supply in the base. The power supply is what blew, so I just removed the LEDs off there, rigged up a new 12-volt power supply, and then I tapped RGB lines off of it to run other RGB, and then you have your remote control dealie here. That's how you control what setting it is. I put an extension wire on that so I can place it elsewhere. I got it hardwired to this strip here designed to go on a fan, but then I have this one here. I guess I'll put that on the water block. Actually, I think I'm gonna fit this after I do the water, which I think I'm almost ready to do now. Like cable management on these guys is notoriously easy because, you know, media boxes got nothing to them. So that generally snaps in there. I don't have my valve in place yet. Guess that gets to be a bit offset. I'm surprised I could bear this much weight. A lot of digging around the scrap tube bin here to try to find pieces that will fit together. I'm not gonna cut on new tube unless I have to. Not for an experiment of this nature. Oh, of course, once we actually get it in practice, it's just a snut too short, isn't it? I just don't, well, hold on here. It says it's not. What is going on? This geometry is messed. Wow, what a little snoot we're gonna need for that. I don't even know if we can cut a piece of tube that short. Unless we already have a piece of tube that short. Well then, we need one short snoot of tube. Can you cut this with this? No, it's wrecked. Now, can I make this one better? I've got a loop formed now, and it's quite, it's something. You know, we got a more looser, I'm not sure how I feel about that. We're gonna have to observe the leak factor, but it should be okay. You know, we got a looser tube going to here, and then we got a short tube with some 90s, rotary 90s going from the block to the rad, and then in a coincidental stroke of fate, this connection from the rad to the reservoir is so tight I couldn't even get normal fittings in there, but these lower profile hard tube fittings, yeah, and I just had a scrap piece of hard tube to link them, so that's kind of hard mounted there. I've actually opted for a shorter link here, so it's not pretty, but it'll do. Well, I just have to finalize on the cable management. My implementation of this is debatably somewhat half-hearted. I'm not bothering with this. I'm gonna cut corners, buds. You're not gonna see it anyway. See, look, cable managed. We're using routing at the front here. The RGB sensor is there, so I can control it with the remote. Now, I just kind of ugly stuck this RGB strip right onto the res. There isn't exactly a better place to stick it right now, short of rearranging on it. And seeing how it's hardwired onto that controller, so I can't just disconnect it. So, yeah, that'll have to do for now. Shorter tube here, make it less likely this thing's gonna rotate out of the way. Should stay better where I put it. And yeah, RGB hooked up to the water block. Now we have to fill this thing. I think it's pretty much ready to go. Yeah. Okay, so I know what you're thinking. How do you fill a loop without a pump? Oh boy, we can't just pull into the res bud, it's not gonna move. So here's the plan that I came up with. We have a spare reservoir, clamped down so it doesn't go anywhere, because it's gonna be open. That feeds into a pump of circumstance that is controlled by my homemade pump controller. Then guess what that's gonna do? Oh, if you said it's gonna pump into the drain valve, you're correct. Because we have a check valve here, it won't let the water go this way into the res. It's gonna force it all the way through the loop, priming the loop, returning back to the reservoir. At some point, the reservoir is gonna overfill, causing the water to flow back out the fill port and return to this reservoir. We should have enough slack here that we can give it the wiggles there to get the bubbles out. Once we get this fully primed and sealed, it should allow us to get this effect that we want. So let's try it. Start off by filling this res up. Let's give the pump a little bit of a go. Yep, it's flowing all the way back in, which brings us to a little bit of a conflict and why we need our foot switch. It'd be nice if this wasn't at an odd angle. All right, busted out the foot switch. We just kind of keep blipping on it. And then while we're blipping on it, we make sure to keep that water level from overflowing. We got it going right slow now. I think we can keep on top of this. Oh, it's starting to pour into the resi. Oh, what's gonna happen? It should start bypassing. This might be all the water we need, let's see. I didn't exactly get that pipe on nice, so hopefully we don't have a leak. We've got water ingressing up these threads here. That's on tight, right? Is that res gonna leak from the top? Like, I don't think that should be able to get up there unless there's, oh boy, I detect a bit of moisture. Oh, this is gonna get tricky, bud. You need a little bit more pump pressure. There it goes. Oh, there's like some fun little effect there. Look at that. Blah, 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 blah. It's like there's bubbles stuck in there. So far, this has taken exactly a liter of water. That should be enough water to get the effect we want. It's just a case of getting all those bubbles out. And of course, yeah, it can't bypass the check valve. Now let's turn her up, get all those bubbles loose. Because of what's going on down here, we don't have to really worry about this catching bubbles that much. Now we start doing this kind of action. Oh yeah, and the big one is to go like this, get the bubbles out of the rad. Full power, is she flowing smooth? So yeah, we're gonna say that this res is slightly sketchy. It's like that needs to be maybe reefed on a bit more. Then we start risking our geometry, right? The hope is that, you know, when we got like heat pressure building up in this loop, it's not gonna leak out anywhere. We don't have to worry too much at the top here because like the water levels are gonna go down a bit. It needs to be continuous, so we can't really have an air gap. So we need to get the water level above that little drop down tube there. But then you kind of do want a bit of air gap to be an expansion chamber. So as the pressure increases, it can kind of compress the air a little bit instead of trying to find a leak to leak out of. But I think that's good. It's such a simple loop. Question is, how do we finish this party? So I'm gonna turn the pump like down, right down, and I'm just gonna do one of these. I'll just turn it off. Okay, so kind of the hope here is that I open the valve with the pump turned off and the reservoir can drain out. We got an air bubble there. Let's try to get it all the way up into the res. There we go. Oh no! It almost went too far. Okay, just a little blip of the pump. Oh, why is there's bubbles bubbling back up in here? Where is that bubbles coming from, bud? That doesn't make any sense. Oh, I think that stupid drop down tube isn't sealed nice. That might mess up things. Now it's just a case of disconnecting this and sealing it up. So I'm gonna secure the valve, pull off this top fitting, put a plug into place. Now one problem is, we might have an air bubble stuck in here because the hope was it could backflow through the check valve. Now we kind of need to pull this res low to get the rest of the water out of the line. You know, that's not really gonna happen. You just have to eat up the fact that we're gonna spill when we take this off. Just securing the res in a permanent loop here, isolated from itself. Now let's take this fitting off. Let's deal with a bit of the drip. Let's put the plug into place. Let's wipe it up. Ah, that was a little less painless than I was expecting. Question is, what happens when we turn this on, bud? Oh boy, we're gonna have to set her up at the test bench, put her through some paces. But I might let it sit for a little while just to make sure we're not getting any other drips or leaks. It is dinner time anyway.